Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in 8051 microcontroller. We're going to see the instruction set of microcontroller. To start with, we will see arithmetic instructions in this particular video. When it comes to arithmetic instructions, we will see about increment and decrement instruction. We will see addition, subtraction, multiplication and division instructions. These instructions is going to be very easy for you. By this time you would have started doing programs using microcontroller in your lab classes. So this concept is going to be very simple, right? So we will start with arithmetic instruction, and as I said before, when it comes to instruction set of 8051, predominantly we will have 5 different types of instructions. One is arithmetic, logical instructions, data transfer instruction, Boolean variable instruction, and program branching instruction. And today we are going to see about arithmetic instructions, right? When we say about arithmetic instructions, it's all about addition, subtraction, multiplication, division, right? And also it will do increment and decrement operations, right? So we know that microcontroller is capable of doing this mathematical calculation, arithmetic calculations, right? And to do that we have to give the instructions, correct? So how the instruction will be, right? These are the mnemonics, that is the instruction which we give to 8051 when it comes to arithmetic instruction, right? So INC is nothing but increment, right? Increment destination, that is whatever destination which is given here, right? It can be an address or register, whatever may be, that will be incremented to 1. Right? And similarly decrement, DEC represents decrement, decrement the value of the destination by 1, right? And this is addition, right? When it comes to addition, you have to be aware of 2 different types of instructions. One is add and add C, right? That is, when it is very simply add, right, then it represents just the addition operation without involving the carry flag, right? It can be the addition between 2 numbers, right, or the content between two registers, something like that, right? But we don't involve the carry flag here when it comes to just add instruction. When the instruction is like this, add C, then it is also an addition instruction which involves the carry flag. Similarly, this is applicable to subtraction instruction as well, right? When we say sub B, then it involves the borrow flag, not the carry flag, right? And we don't have the information about the carry flag, the instruction about carry flag in multiplication and division, right? Only if the result of multiplication exceeds, right, then we will set the the microcontroller will set the overflow flag, right? So coming back here, you can see this is nothing but increment the destination. It will increment the destination by 1, and this instruction will decrement the destination by 1, right? And when it comes to add, it will just add the destination and source. And when it comes to add C, it will add the destination, source, and as well as the carry flag, right? And similarly here, what will happen? Subtract destination, source, right? So here it also involves the carry flag, right? So the subtraction involves with carry, source, and destination. And when it comes to multiple AB, this instruction is just a direct instruction where the content of A and content of B will be multiplied, right? And similarly, when it comes to division, the content of A is divided by B, right? And this is very important instruction, which is DAA. What is DAA? Is nothing but a decimal adjust accumulator, right? So what does it mean, decimal adjust accumulator? This instruction is used to convert your result, right? In most of the arithmetic operation, the results will be saved in the accumulator, correct? So this instruction, that is DAA, what it will do is it will convert the result in the accumulator to the correct BCD form. What is BCD form? Binary coded decimal. If you don't understand what is binary coded decimal, we have posted a lot of videos regarding binary to binary coded conversion, right? You can go and check that in computer architecture playlist. Okay, so binary coded decimal conversion. That is, if the accumulator value is not in the correct BCD form, it will correct it to the BCD form. What is the BCD form? BCD form, whenever a number exceeds, right, whenever the number exceeds above 9, right, so what it will do is it will add 6 to that particular value, right. So whenever the accumulator value is greater than, that is, it can be a lower nibble or higher nibble. Say for example, if it is accumulator is an 8-bit, you can see here we are representing it, right. So this is lower nibble and this is higher nibble. If the lower nibble is greater than 9, and what it will do is this particular instruction, it will correct it to the correct BCD form by adding 6 to it. Similarly, this can be done for higher nibble as well. So this instruction DAA is nothing but it will convert the result of the accumulator to the correct BCD form, right. So with this basics, we will see the instructions now, right. As I said, you can see increment A, something but it will increment the accumulator value by 1. And I have already said what is RR and what is RP, right. It's nothing but RR represents the register, any of the register, and RP is about the register pair, right. And we have seen the last video about the addressing modes, right. If this represents, it represents the indirect addressing mode, and whenever you come across this symbol, that represents the immediate addressing, right. So by this time you should be able to understand what is direct addressing mode, what is indirect addressing mode, so that when you are using in the instruction, it will be very easy for you, right. And similarly, you can see here increment address, that is, this will increment the given address value by 1. And you can see here, what does it mean, increment at RP? Here it is indirect addressing. Indirect addressing in the sense the address mentioned, right, in the RP, right, that has to be incremented, right. So the address which is mentioned in the RP, right, that has to be incremented by 1. You can see add 1 to the content of the address in the RP, right. And similarly, you can see here this is direct, that is, we are giving the address directly, but here we are giving the address at the RP. To get the address, microcontroller will go to RP and check it out, right. But this instruction will directly increase the address value. This instruction, what it will do is it will increase the address of the RP, right, the address value which is present in the RP. Similarly, you have something called increment DPTR. You know what is DPTR? For accessing the external address, right, we use DPTR, right. So increment DPTR, it increase the DPTR value by 1. The same thing applicable for decrement. Decrement A, decrement the register, decrement the address, decrement the indirect address, right. And one thing here, you don't have any instruction decrement DPTR. We cannot decrement DPTR in 8051, right. So apart from it, we know that all are 8-bit addresses and the content overflow when f of h when there is a rollover from f of h to 00h. And similarly, DPTR will overflow from after reaching this maximum content, right. And whenever in any arithmetic operation, whenever there is an overflow, right, and whenever there is a carry, we already seen about the conditional flags, right. So whenever there is a carry, the carry flag will be enabled. Whenever there is an overflow, the overflow flag will be enabled, correct, right. And this is about the arithmetic operation. I have already explained about the arithmetic operation, right. We will see by instructions here, right. You can see here add a comma hash n, right. Whenever you come across this hash n, I said that this is about the immediate addressing. What does it mean? We will directly give the value of that, directly give the data to the instruction by using immediate addressing, right. So you can see here in all this instruction, right, whenever you use any particular instruction, you will have destination comma source, which means whatever operation which we do, that will be saved in this destination. You can see here in all this instruction, destination is accumulator. Most of the arithmetic operation, the accumulator will be the destination, right. So what does it mean now? Add this number with the accumulator, right, and place the result in the accumulator. Similarly, add the content in the register R with accumulator and place the result in the accumulator. Similarly, add the address content with A and place the result in the accumulator. Right. Similarly, add the content represented the address RP with accumulator and place the result in the accumulator. The same instruction. Okay. But as I said, whenever there is a carry, right, the carry flag has to be set. Right. And whenever, when the auxiliary carry flag will be enabled, whenever there is a carry from lower nibble to higher nibble, then the auxiliary carry flag will be enabled. Similarly, whenever the overflow happens, if the result is more than 8-bit, right, then overflow flag will be enabled, right? And I've said what is addition C, that is add C operation. Everything is same. Only one difference is you will have to add carry flag with it, right? You can see add C. Before that instruction, what we have done is without C, we have just add A and N and place the result in A. Now what we have to do is we have to add A, N and as well as C. Similarly here we have to add A, the address content and as well as the C. Similarly the content in RR and A and as well as C. Similarly here, right? The same instruction, all we have to do here is we have to involve carry flag here, right? And when it comes to subtraction, right, the same rules which is applicable for addition, that is the same rule here in subtraction, right? As I said, whenever you use instruction sub B, right, if it is sub, then it is represented to subtraction, but sub B represents to the borrow flag, right? So as like addition, this subtraction, right, it not only subtracts this value from the accumulator, what it does is it will subtract the immediate number and the carry flag from the A, right, and put the result in the accumulator. So it involves the carry flag. So it subtracts the address value and the accumulator and the carry flag. Even here the content of RR and then C and then accumulator and place the result in accumulator. And same thing is applicable here, right? So subtraction is same like the addition. All you have to understand is if it is sub B, then it denotes that carry flag is enabled. That is the borrow flag is enabled, right? And when it comes to multiplication and division, it is going to be a direct instruction. Only one thing will be changed here, that is saving of result. So far what we have done is whatever result which we obtained, that will be saved in the accumulator. But here since you will have both lower byte and as well as higher byte, right, the result will be saved differently here. That is, you can see here, multiply A comma B is nothing but multiply the content of A by B, right? And now you'll get a result. In that result, the lower order byte will be placed in A and higher order byte will be placed in B. Lower order will be placed in A and higher order will be placed in B. Similarly, division. When it comes to division, right, it's going to be, we're going to divide A by B, but you will have quotient and as well as remainder, right? The quotient will be saved in A and remainder will be saved in B, right? And we know that whenever the multiplied content is greater than the 8 bits, right, then definitely a overflow flag has to be enabled, right? So, and similarly in division, the overflow flag is enabled when it is set up to division by 0, right? So this is about the arithmetic operation. And as I said, the last instruction which is very important is a DAA, that is decimal adjust accumulator. I have already explained that whenever we add, right, and understand one particular thing, this BCD instruction is applicable only for addition, right, not for multiplication, subtraction and division, right? So all it does here is it will adjust the accumulator to the correct BCD form. Say for example, you can see here, if the accumulator is already having 59, right, and this instruction, what it will do is it will add 1 to this accumulator, and definitely the accumulator value will become 5A into the EXA value, right? Then if you use this DAA, now what it will do is it will adjust the accumulator to the correct BCD form, which is 60, right? So this is the information about the arithmetic instruction. So this tabulation is about the summary of whatever we saw so far, right? In this you can see here when it comes to add A and byte, right? You can see all these instructions, right? All these three instructions, right? It involves a direct addressing mode, indirect addressing mode, register and immediate addressing, right? and this increment A, it's involve only accumulator, right? This just represents which instruction uses what are the addressing modes, and similarly the execution time of each and every instruction. Just a summary of what we have seen, right? So today what we have seen is we have seen the arithmetic instructions of 8051. We have seen what is addition, what is subtraction, and what is multiplication and division instruction. All these concepts are very simple. Only thing you have to understand is what is DAA instruction. If you understand that, then all these instructions are very simple, right? I hope this video will be very useful for you, my dear students. Thank you.
Thank you students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.